Thank you very much for inviting me to give you a rundown, basically. Alex has done the 4. I'm left with tidal flooding, which is a big issue for London. And also, a chance perhaps for me to knock some of the misconceptions that have been out in different forms of media. The media sometimes get it wrong. And we need to just make sure that people realise that the barrier will not actually fail in 2030. The world will be a changed world by 2030 to some extent, but the barrier won't fail. That we don't actually need new barrages or islands coming across the front of the estuary, turning our natural estuary that's improving into something totally unnatural. And we will not get a tsunami wave coming up the Thames, as ITV showed us at Easter on the flood movie. So what will we get? Well, that's, as Alex has shown you, this is the whole estuary, the map, and showing you that's at risk from tidal flooding, and that the dark blue areas are those areas that are at risk from tidal flooding. Those areas would flood if we didn't have the defence system we have now. If we then stopped maintaining what we've got now, they would flood. And they would flood on every high tide, most of those areas. So we're used to living at risk of flooding in London and in the estuary. London's been living at that risk for hundreds of years. We built the City of London, and you can see the asset base there. Now, I'm sure we'll talk more about economic value, but we've got £80 billion worth of property at least. Now, that's got nothing to do with the business impact of those businesses stopping working if they were to flood. That's just the assets. So that's what's at risk. That risk is increasing, and it's increasing because we're going to have more intense storm surges. We're going to have increased tides, all due to climate change, all due to sea level rise. We're going to have increased rainfall, as Alex said. And we've also got an additional problem here in the southeast, where we've been recovering now for a long time from the glaciers that held the north down. So the north is tipping up, and the south has been tipping down by about 1 to 2 centimetres a year, millimetres a year. So we're looking in the agency to plan. The Thames Barrier was built following the 1953 floods and all the associated defences. We had a huge surge tide coming down the North Sea that caused flooding, catastrophic flooding in Canvey Island and some parts of the outer estuary, huge flooding in Holland. And the reaction to that was to build our Thames Barrier. So we planned for that uncertainty, but we're looking to say, well, what happens up to the end of the century? Because the Thames Barrier was designed to last until 2030, and last meant that the design was for 1 in 1,000 protection, which, as Alex said, is a very high level of protection compared with the rest of the country and the rest of the world, in 2030. So it was designed taking account of sea level rise. It was designed taking account of the fact that the southeast was dipping. So they built into the system they put in an allowance for that change up to 2030. So on their design life, by 2030, it would start decreasing from 1 in 1,000. That's what they believed. So we decided in 2000 and convinced the government that we ought to have a project that says, well, what do we do next? And what is the future we need to plan against? And what should we do? Or what should we react to it? The project now has been going since 2002, and we've come up with 4 different ways that we could manage flood risk to the end of the century, 4 different types of options. And you can see there we've called them traditional engineering floodplain storage, having a new Thames Barrier, which could be a totally new one, or keeping the existing one and building another one and running them in tandem. Or we could have a new barrage. For those of you that are not aware, we take a barrier to be a device that only closes on a very high tide, and other than that wouldn't restrict flow. Whereas a barrage will be closed and maintain a level behind it at all times. So it changes the estuary greatly. We've taken those options and we've tested them with what-ifs. The first one we have to test against is what the government tells us that we should design to expect. And that's a 0.94 metre rise in sea levels by the end of the century. So we've looked at what would happen to our options in that sort of scenario. We've gone on from there and taken UK SIP's medium-high scenario, which is 1.5 by the end of the century, and tested them again. But then we've gone even further, and that's something we know no one else is doing in this country, but given the scale of the risk and the issues that we need to worry about in London and the southeast, we've tested against two other scenarios. The high plus scenario takes UK SIP and then adds to it an increase in surge. Because as I say, the problem that we've got in the estuary, the risk we've got from tidal flooding is not to do with high spring tides. It's to do with a high spring tide or any high tide combined with a surge. So if we get a low pressure in the North Sea that starts in Scotland and works its way down the east coast, that low pressure pulls up the water into like a saucer of water that comes down that coast. That's what happened in 53. The water comes down the coast and then it gets compressed as it gets to the channel. And it has two choices. It goes to Holland or it comes up the estuary. And those surge tides can add 3 meters plus to a high tide. Now that's the risk we're facing. So that's what we've had to design against. So the high plus is taken the conditions we've got now, taken the UK medium SIP of 1.5 and said we might get, it's possible to get even higher surge tides than that due to the storminess. So we've added on to that. And then the last one, the plus plus, which is the catastrophic situation by the end of the century, we've taken advice from any reputable scientist of what could happen regarding ice melt. What's the worst we could really expect if all the land-based ice were to melt that could melt by the end of the century? And that would give us a 4.2 meter rise. So those are our scenarios that we've tested our options against. And we're continuing to test because the project doesn't finish until the end of 2009. So we're still doing more science. But these are the results where we've got to at the moment. So you can look at our options. And if you follow the boxes through, we start from raising defences, which we're planning to do to a small extent throughout the estuary anyway. But then we could over-rotate the barrier. So the barrier is designed to come out of the bed of the river and come up. It could come up further and give us a higher level of protection. But that would mean raising the defences further downstream as well by the same amount. And we could do even more improvements later on. It's not quite as crude as welding a bit on, but we could do even more to the existing barrier. And in doing that, you can see we could actually manage to cope and keep the same level of protection as we have now, above 2 meter rise in sea levels. So if we had a 2 meter rise in sea levels, that approach would be okay. The other approaches you can see have a higher standard. Basically, you can get, if we were to find flood storage, which sounds like a really good option, so that we can give the river room to expand into on a very high tide, that brings levels down. We can again do more engineering, and that gets us to about 2.5 meters. We could build a new Thames Barrier. We could build an additional Thames Barrier, and that's what the last one there, it says new barrier. Sorry, the new barrier and retaining existing is having two barriers in tandem. So the Thames Barrier, as it stands now, would close on the levels that we've been protecting against. If we had an even higher event, we'd close the one that would be further to the east. We could do that, and that would give us protection of 3 meters. And finally, if we built a barrage across somewhere near the mouth of the actual estuary, we could provide protection up to and above 4 meters, probably up to 5 meters. So that's the sort of things we could do in this uncertain future. But what we've learned from the studies we've done, we've been out and looked at what was actually built, and as I say, that they knew, the people that built the Thames Barrier and that system, that sea levels were rising. They knew the southeast was dipping. They made allowances for that understanding and built what they built. We've actually found that their safety margins were greater than we would have expected. So we're at a higher standard of protection than we believed we were. And due to that, and the actual condition of the majority of defences, we think it's unlikely that we'll see major expenditure required before 2030. After 2030, we'll see that expenditure starting to ramp up, maintaining and replacing the existing assets. As Alex said, the consequences are so high for tidal flooding. I mean, if the defences were to fail or to be breached, the consequence would be huge. But the likelihood is very low. So we need to make sure that we keep that likelihood in that position by maintaining what we've got to the state it should be maintained. And that's probably our plea to the government, that we have enough money to maintain what we've got, because it's much better money spent than it is waiting to build something new when what you've got falls down. We spend at the moment, just in London, around 15 million a year keeping those defences in the condition they should be. So in summary, we've found ways that you could make sure the estuary is protected from tidal flooding up to the end of the century. And that's even if the very worst situation were to happen. There are ways that could be done. But the more we do to reduce the emissions that are causing climate change, the better. And that's, I suppose, what we're saying to the government, or what we will be saying to the government. We would suggest you take the option that maintains the risk at an appropriate level, but don't do what you don't need to do. So don't go ahead and build a barrage now, because you don't need it now, and you may never need it if we get the tipping point well before 4 metres. Then it would be a waste of expenditure. It would also change what is a natural estuary that's starting to thrive, and we've gone from a dead river in the 50s to an extremely live river now full of 120 plus species, and it's getting better all the time. And when we get the tideway tunnel built underneath the river, that would be sewage problems gone for a long time. So the river is getting better, the estuary is getting better. We don't want to lose that. But if we have to, if we get to the nightmare scenario, that's what we'd need to face. And basically, we need to work, as Alex said, to reduce the other flooding problems in London, which are much more likely. Thank you.